Hello and welcome to PEEPanEIP, an EIP dedicated series to discuss an Ethereum improvement proposal and understand how it is going to help Ethereum ecosystem. I'm your host Pooja Ranjan, and with me we have Runchao Swap and William Shaw from Ethereum Cat Herders. Before we proceed, a quick reminder: if you have missed any proposal that we discussed in earlier episodes, you may follow the recording available on PEEPanEIP playlist at Ethereum Cat Herders YouTube. So today we are going to have an overview of EIP-2266 Atomic Swap based American call option contract standard. And we have got with us two of the co-authors of the proposal, Runchao and Chris. This is a standard track ERC, which was documented in August 2019. At present, it is in last call. So welcome to the show. Let us have a quick intro and a little bit about you, how you got into Ethereum, and then we'll go ahead with overview of the proposal. If time permits, we have a few questions for you.
Hi. Hello, Ethereum folk. I'm Haoyu. You can also call me Chris. So I'm so glad that today I have a chance to give a talk on the EIP we propose, namely EIP-2266, Atomic Swap-based American Core Option Contract Standard. We've been focusing in and interested in Ethereum ecosystem for a long time because it's really well developed and it's very friendly to blockchain developer, and the ecosystem is quite hot for so many years. And today I will be talking about what is this EIP for and why we think this EIP should be moved to the next state. So this EIP is based on a paper Runchao, I, and Jiangshan co-author on the optionality and fairness of atomic swap. The paper also gets accepted in AFT19, namely the first ACM conference on advance in financial technology 2019. You can get access to the paper by this link. So Runchao is a PhD student from National University in Data 61, and his research interests include blockchain scalability, decentralization, and egalitarianism. And I myself is co-founding a ZH rollup layer 2 DEX on Ethereum, code-free DEX. Feel free to contact me if you want to learn about this project. And Jiangshan is an assistant professor in Monash University working on blockchain, cybersecurity, and cryptography. So to begin with, let's take a look at how people could exchange some cryptocurrencies across different blockchain. So on blockchain, let's say Alex wants to exchange 1 BTC with Bob and get 10 ETH. We then need an exchange or maybe a trusted third party. Otherwise, if Alex sends 1 BTC to Bob, she is not sure whether Bob will send her back 10 ETH, and he just lose her 1 BTC forever. So if they both trust the third party, like the exchange here, they trust the third party is honest, then they could just assume that the third party will send their assets on behalf of them if the third party receive assets from both sides. Or if one of the counterparty is cheating, they just assume the third party will send their asset back. So that in this way, they can complete the exchange of the cryptocurrency successfully. In fact, in many cross-chain protocols, there also exists a cross-chain federation controlled and or managed or run by multiple identities with an honest majority assumption. This is still kind of like semi-trusted because you still need to assume that the majority of the federation won't collude or they are just hard to compromise. But what if we want to do it without an exchange, or let's say without a trustee third party? Can Alex and Bob do the exchange without a third party in the middle? We can just we can in fact use hash-time lock contract HTLC to overcome this problem. So hash-time lock contract can enable two parties to exchange their own cryptocurrency atomically, which means the transaction will either both succeed or both fail. This scheme is called atomic swap. It's an atomic transaction that just swapped two kinds of cryptocurrency together. So how atomic swap work is illustrates as follows. So as you can see from the diagram, Alex deposits S1 on blockchain 1 with a time lock, with a hash lock and a time lock. She knows the pre-image of the hash lock, but she cannot refund before the time lock expires. Once Bob sees this transaction, he also deposits asset 2 on blockchain 2 with a same hash lock and a time lock. Again, he cannot refund asset 2 before the time lock expires either. Then, once Alex sees this transaction sent by Bob on blockchain 2, he could just redeem the asset. I see here, she could redeem the asset 2 on blockchain 2 because these two transactions use a same hash lock. That means the pre-image of these two transaction hash lock is the same. So Alex actually knows the pre-image of this transaction's hash lock. In this way, she could redeem asset 2. Once Alex redeems asset 2, the pre-image gets revealed, and then Bob can read from the transaction, the redeeming transaction sent by Alex. He now knows the pre-image as well. He can also redeem S1 on blockchain 1 using this pre-image. If Alex doesn't redeem at all and the time lock expires, both of them just refund their asset back. This is very suitable for a cross-chain DEX scheme. That is, it doesn't require a trustee third party at all, as you see from.
Yeah, I got a couple questions too.
So the example you originally gave is, let's say Alice is 1 BTC and Bob has 10 ETH, and they would like to exchange the two of those. So that would make the first blockchain the Bitcoin blockchain, and then the second blockchain the Ethereum blockchain. But then we have the asset 2 that's being deposited by Bob somehow landing inside blockchain 1. So how does that work if we're dealing with blockchains that don't support both assets being almost natively? Like, I could understand that the Bitcoin, when it exits into the Ethereum ecosystem, may actually be interacting with a wrapped Bitcoin protocol like REN or WBTC. But what happens to that ether when Alice wants to access it?
They don't have to like to wrap into Ethereum, because we are actually operating on two different blockchains, and if they are on one blockchain, in fact there's no it's unnecessary to do this, because you could just send two transactions atomically in one smart contract call, right?
But I'm not sure I was clear. How do we deal with assets being transferred when they're not supported on both blockchains? And when Alice pays out her BTC, is Bob receiving that in the Ethereum blockchain, or is he receiving that at an address he controls in the Bitcoin blockchain?
Let's say S1 is BTC, and blockchain 1 is BTC chain, right? And blockchain 2 is Ethereum chain, and blockchain 2 is Ethereum chain, and ASIC 2 is ETH. And in fact, Alex and Bob, they both need an account, or let's say address on these two blockchain.
Okay, I understand what you're saying. Got it.
Yeah. So so they actually redeem using their own address. Yes.
So there's blockchain 1 that shows the line, and blockchain 2 that shows the line, and those, you've got the initiate block and the participate block. Those are contracts running on Ether. And then there's the alt block. Are all three of those blocks contracts running on Ether that have hashes into the blockchain 2 or something like that?
Well, like for the initiate block, it's on, let's say, BTC chain, blockchain 1, and participate is on Ethereum, blockchain 2. So as long as they use a same hash lock, that means the pre-image of these two locks are the same, they could be unlocked using one pre-image.
Okay, that helps. And the bottom one, the alt, is that, so which chain does the bottom the alt one that coordinates those two together? Is that an Ether contract?
It doesn't necessary to be a contract. Like, so this line is on blockchain 1,
which is Bitcoin, right?
Yeah, and this is
blockchain 2, which is Ether.
Yeah, Ethereum. So like for this block, we draw this just to tell the time frame.
Oh, yeah, so this isn't a contract of the bottom block. This is just a display of the time frame.
Yeah.
Oh, yeah. Okay, that helps. Cool, thanks.
So I guess we can move on. So if Alex don't redeem at all and the time lock expires, both of them could just refund their asset back. This is very suitable for a cross-chain DEX scheme. That is, it doesn't require a trustee third party at all. We don't have any trustee third party during this scheme. So that means it's in fact a non-custodial scheme. For example, Atomic, Runchao network, and Jelly are using Atomic Swap for their cross-chain transaction. However, it is noticed that Atomic Swap is unfair to the swap participant, which means there is optionality. Now, let me explain optionality briefly. So, taking the definitions from Investopedia. So in finance, an option is a contract which give the option buyer the right but not the obligation to buy or sell an underlying asset at a specified price or on or prior to a specified date, depending on the form of the option. So that's the kind of formal definition. So in terms of the HTLC-based atomic swap example, HTLC-based atomic swap has optionality that the swap initiator can choose to proceed or abort the swap for several hours, which gives him time for speculating according to the exchange rate. As you can see from the diagram, the price of BTC Ethereum pair might fluctuate. If the price is stable, Alex will probably proceed a swap. Alex and Bob will both be happy. Well, but if BTC price goes up relatively, Alex can choose to abort the swap because he could be able to get more ETH by using the most recent price. This makes Bob unhappy because the deal is cancelled. And if BTC price goes down relatively, Alex will probably proceed the swap, which makes Bob unhappy again because she should be able to get more BTC by using the most recent price. There actually are different kinds of option. Like we have American option, European option, call option, and put option. In fact, atomic swap is equivalent to American call option. This is also discussed on a discussion on Bitcoin mailing list. You can see from the diagram that in American call option, Alex need to both deposit the asset she wants to sell and deposit premium. However, in atomic swap, Alex deposits no premium at all, and this leads to Alex optionality. Well, in our paper, we qualified the unfairness by analyzing the volatility. We collected data from March 5th, 2018 to March 5th, 2019. So that is 1 year data, including 8 pairs of cryptocurrencies and 2 pairs of foreign exchange and 2 stock indices. We observed that the volatility of cryptocurrency is greater than stock indices, and those of stock indices are greater than foreign exchanges. So cryptocurrencies are greater than stocks and greater than foreign exchange. We use CRR model, Cross-Robertson model, CRR model to estimate the premium and come to the conclusion that the premium should be approximately 2% to 3% of the asset value for most cryptocurrency. While the premiums for stocks and fiat currency is approximately 0.3%. This means it's much more unfair in the cryptocurrency case. So for fiat, that's approximately 0.3%, but for cryptocurrency, it's obviously higher. Therefore, we propose our version of atomic swap protocol, which exploits the optionality in atomic swap to implement American co-option to fix this problem. So basically, Alex needs to deposit premium on blockchain in addition. So Alex, in addition, deposit premium to blockchain 2 as well. Note that such a protocol can not only be used for an American co-option, but also a currency exchange scheme. If it's a currency exchange scheme, later it's Alex who is going to redeem the premium. If it's an American co-option case, it's Bob who is going to redeem the premium. So adding premium here mitigates the optionality in the original atomic swap protocol. Let me explain why we can mitigate such optionality. So if Alex behaves maliciously here, Bob can see Alex behaving maliciously and decide not to participate into the protocol. If Bob does not deposit his assets here, Alex can refund both asset 1 and premium. That means if Bob behave dishonestly, Alex could just cancel Bob the protocol. But if Alex do not redeem Bob asset, like the previous case we described, once the price fluctuates, Alex may not want to move on the protocol again. So if Alex does not redeem Bob's asset, asset 2's time lock will expire, and Bob can just refund asset 2. Also, Bob can refund premiums according to the protocol. That means if Alex doesn't want to continue at all, Bob will just get asset 2 and premiums. This is kind of like incentivization mechanism to make Alex would like to proceed the protocol, because if she doesn't proceed the protocol, he would just lose his premium. So there are actually some other consideration. So for example, the asset 1 time lock Alex used should cover the whole swap process, and the participant should never the participant who is Bob here should never participate before the premium has been deposited. So Bob only participates into the protocol once he sees Alex complete depositing premium. This EIP is at establishing a standard for atomic swap protocol. So we actually define the interfaces of our version of our more fair version of atomic swap, and define some technical terms. And we also define the event and provide a reference implementation on the link on the screen. You can find our implementation here. So this EIP aims at establishing a standard for atomic swap protocol to mitigate the unfairness inside the original protocol. By standardizing the protocol, we believe that it helps atomic swap being more used, which makes cross-chain exchange more decentralized because you don't need a trustee third party. Moreover, this standard can be used to build trustless DEX for option derivatives because the protocol could just support the European option easily just by fixing the height of settlement. And because so many good things that this EIP brings, so that's why we think this EIP should be moved to the next state. Thanks. That's my talk today. Yeah, thanks.
By next stage, you mean, because currently it's in status last call, right? And the next stage would be final?
Right.
Sorry? Mm-hmm.
Yeah, right. Currently, the EIP is in the status of last call, and next date is final. Ideally, in last call, a proposal is there for only 2 weeks, but I see this has been a little longer than the expected time. I'm not sure. I found this comment by one of the EIP editors on the proposal about the standardization, as you explained that this brings a lot of good things for DEX and other atomic swap options. So just being curious, this is specifically to the Americans, correct?
Like it's very similar to American co option, but you can actually like refactor it to European option as well.
I see. Yeah, because the comment states that this is a good idea, but every DApp can implement it in their own way and it won't break anything for the other DApp. So for standardization, we generally prefer that a proposal should be standard for every DApp or something, like it's not specific to one application. So I just want to be clear on that part.
Okay, yeah, that makes very sense. Yes.
So related to that, you mentioned in one of your slides about implementation of atomic swap in Atomex and a couple of other projects. So are they using this particular version, like the proposal, or they are using a different version of that?
Well, they only use the original version without premiums. So in their protocols, they are actually optionality. Yes. So that's the weakness of their atomic swap. Yeah.
Okay, got it.
Outside the incentives, I think this might be a rephrasing of what Pucho was asking, but the way that you've presented it, the major advantage of using the structure that you outlined for an atomic swap is in the incentivization, that the parties are better incentivized than they would be without the premiums built into the structure. From the technical side, is there the specification that you outline in the EIP? Is there a specific reason why you see that specification to get to having premiums attached to an atomic swap is better than perhaps alternative ways to implement this? Like, is there what considerations do you see that led to the specification the way that you specify it in order to have premiums?
Well, because by comparing to American co-option, like you can find out that there's optionality in atomic swap because there wasn't premiums. By adding premiums, you can mitigate the optionality. And
maybe
like
I can.
it's a really like it's also really tricky that maybe like the both sides need to decide like they need to find out a way to agree on how much value is the premiums beforehand.
Maybe I can rephrase Chris' interpretation in another way. So basically, for the original atomic swap protocol, it's pretty cool, but there is a weakness which makes the protocol unfair. So namely, there is a free arbitrage strategy for the allies, and so our protocol basically fixes this problem. Then after fixing this problem, so our protocol becomes an American core option protocol based on this atomic swap, and it is fair. So that's what we seek to solve. And for the existing decentralized exchanges using the original version, so there are always the arbitrage opportunities for the swap initiators. So that might also be a reason that the AMM-based approach is more popular.
I think I have a good understanding of why the incentives are better, why it is better to put the premium in. But I guess the direction that I'm trying to go on is there a particular technical challenge that you are looking to solve? I mean, assuming that I totally agree with you that having the American call option premium built in aligns incentives better and eliminates the free arbitrage opportunity that you were talking about. What technical challenges are there in implementing this? In trying to implement this kind of a structure in order to guarantee that kind of fairness, like from the technical side, what specific difficulties need to be overcome?
So basically, at the point we write the paper, we cannot find a standard way for writing an atomic swap protocol, and they have different parameters and different considerations. And what our EIP do is to kind of standardize this process, and we tried our best to make the specification flexible for most of the implementation styles. So, and
in addition, I
another
think
part. Yeah, go on. Go ahead.
Okay. So I think the most difficult part, or let's say challenge, is to decide the time lock, like when could one of the party can participate into the protocol and when should they redeem the premium. Like the challenge is you need to really decide the time lock carefully so that there's no chance that either party can misbehave. Like for example, if you allowed redeeming premiums too early, then Alex may just redeem the premium and then Bob gets nothing. Yeah, I think that's the challenge.
That's exactly what our second point. Yeah, so basically, as we know in the blockchain, there is actually no time, or I mean precise time. Instead, there are the height of the block, and the block comes up kind of randomly, also with a mathematical expectation. So how to define this time, the length of this time lock can be very tricky. Yeah.
So these numbers 24 and 48, you're saying they're not arbitrary, like as in these are, was that a conclusion you arrived at, that having the sort of 24 and 48 hour, or?
Well, that's because this time frame is commonly used in Lightning Network.
It's interesting that you mentioned Lightning, actually, because one of the other things I wanted to ask is that throughout the slides you talked about HTLC, hash time lock contracts, which are predominantly a Bitcoin concept. Is there a specific reason that you believe that that is what should be used as the kind of escrow mechanism inside Ethereum also? Or would you also consider other smart contract architectures in order to hold the funds in escrow to accomplish a similar goal? And I guess if I ask this in a different way, I could ask, why do you insist? I guess insist is a strong word, but the standard assumes, I guess, HTLC. And is there a specific reason for that?
Well, because we have HTLC on both different blockchains. So our protocol doesn't work only on Ethereum. So it works like basically all kinds of blockchain. So it works quite generally.
So you're saying even though you're suggesting this is an EIP or an ERC, by keeping it to HTLC, one of the things that you guarantee is that it can. There's also a framework here for building on a UTXO Bitcoin style blockchain.
Yeah.
As in the standard's a bit larger than just Ethereum this way.
Yeah. Actually, in our paper, we also have an implementation on across UTXO blockchain. Like we have implementation across UTXO blockchains and smart contract blockchains, and between UTXO blockchain and smart contract blockchain. So it is quite a generous, yeah.
Interesting.
But we think it helps the Ethereum system, so we propose it as an EIP. Yeah.
Certainly. Interesting.
Kind of a generic protocol. Yeah, go ahead.
No, go ahead. I was going to ask a different question, so if you've got more to add here, go for it.
Okay, so basically, as long as the smart contract, regardless of the blockchain, support the HTLC and the kind of the access of the block height, then we can implement this protocol over this smart contract. And I think for most current blockchains, they support basic smart contracts. So it's perfectly okay to implement our protocol. And the suit of the interface that not only applies to Ethereum, but also those blockchains with smart contracts.
Mm-hmm. Yeah, I think it's really a good idea to introduce into Ethereum because there are many like different assets like cross-chain into Ethereum. Like we have WPDS, BTC, Run BTC, TBDC. Like we have different version of assets on other blockchain. We just map them onto Ethereum, and if using our scheme, we could just use a more fair and more decentralized version for their cross-chain protocol. Because as far as I know, most of them use federation scheme, so which you still need to have a bit trust inside, and like for some other protocol, maybe it's more decentralized, but they introduce some kind of like game theories or other stuff. Yeah. Mm-hmm. But like the most decentralized one for now, the most decentralized scheme for cross-chain transaction is still is using HTLC. Yeah.
Mm-hmm. Interesting. But from a smart contract kind of perspective, it wouldn't need to be an HTLC contract per se. No, I mean, at this, you could envision a different kind of decentralized escrow scheme that wasn't necessarily based off of a hash preimage. Is that correct? As in the HTLC would not be a hard requirement on smart contract chains.
Basically, it's the HTLC-based approach is the most popular one. And another solution is based on something called adaptive signature. And the idea is also similar to the HTLC, but they construct a different crypto primitive, which embeds a pre-image. And so far, I'm not aware of any other atomic swap protocols that's not based on these two primitives.
Okay. I hear what you're saying. The primary use of the protocol as you've presented it is for swapping assets that live on two different chains. Can you see other ramifications of this aside from atomic swaps of assets? Have you thought about maybe implications for just committing and revealing information or payments for information, whistleblower protocols or things like that? Or has your focus been strictly in the financial so far?
Well, we were focusing on financial, but I think you really make a good point. Like we can maybe like have some data marquee or something else. Like you can just commit some valuable data and then maybe try to sell and review it on other chain. Yeah, that's a really cool idea. Yeah.
Thank you.
Yeah, maybe there we can do some extensions over this protocol to support such maybe data exchange or something like that. Yeah.
Cool, great. Thanks for the answers, guys. You're muted, Pooja.
Sorry. Thank you both, Runchao and Chris, for explaining those. I'm just curious on one last part on the implementation. Are we aware of any project that are currently implementing this, or we just have the reference implementation?
Well,
maybe you go ahead. Yeah.
I think that's the only implementation. I think our implementation is the only one we can find. Like for other implementation, they are still for the original atomic swap version. Like for yes, they don't have a premium mechanism inside. Yeah.
Yeah. As far as I know, there is one, and it's called a mini swap, and they seem to have an implementation on this part. As Jiangshan, namely my advisor, and also the cause of this paper is advising that company, and as basically this is a university project, and so we didn't kind of advertise this much, but hopefully, and also due to the hype of the automated market maker based approach, the HTLC Atomic Swap approach is kind of not that popular. And so I'm not sure if it's possible for this protocol to support the, option markets rather than the current just currency exchange markets. So that might be an opportunity. So I'm still digging into this part and to see if some companies are still will be interested in this protocol or not. Yeah.
Yeah, that would be great. I hope that with the release of this episodes, we discuss some of the limitation. It's going to help app developers, and maybe it would be implemented soon. I have one last question on the process part. As I can see in the proposal, the discussion tool link is pointing towards the issue section of the EIP repository. The proposal is created in 2019, so I can understand that it was a normal practice to create a discussion link and then eventually end up writing a proposal and submitting it. But recently, the Process Improvement Group, EIP-EIP, is recommending to move any proposal related to discussion in the Fellowship of Ethereum Magician. I have found a discussion there. I mean, I believe you guys have created a link, but it is not updated with the proposal number. We generally suggest to move it to Fellowship of Ethereum Magician because that's increase the visibility of the proposal. And even if the proposal is standardized, if you close the issue on the EIP repository, it's still open and people come and give feedback. So do you have thoughts on updating the discussion to a link to the Fellowship of Ethereum Magician?
Well, we post on Magician forum for 2 times, but we don't really receive some useful feedback. Yes.
Maybe because the EIP number is missing there. I see that it is EIP-XXX fair atomic swap contract. So if you go ahead and update the proposal number, that will help you get the attention that we are looking for this proposal to move forward.
Okay.
I see the problem there. I see. Thanks for making this point.
Yeah.
Okay.
Yeah.
I hope that helps. And also in the EIP, we would want that to be updated. Instead of issue, you can just replace it with the Fellowship of Ethereum Magician. So it will be easier for even EIP editor to go back and refer to that discussion.
Okay.
Very
So
well.
that means we need to specify our EIP number more clearly and link back to the issue here, right?
Right.
Thanks.
So right on time, that concludes all the questions at my end. Does anyone have any more questions or quick summary if you guys want to provide about the proposal? Well, a fun fact, atomic swaps are here for a while. They first came into prominence in September 2017 when an atomic swap between Decreed, DCR, and Light Client was conducted. Really appreciate you both taking out time and sharing this information. The presentation was awesome, and I hope it gets the attention of L2 projects and maybe implemented soon. Also, the proposals may move ahead with the standardization process. On that note, for our YouTube viewers, the presentation and other resources for this proposal are available in the description section. If you have any question that couldn't be answered today, you may leave a comment or ask the author. Their Twitter handle and GitHub will be provided in the description section. Do let us know how you like this episode and which EIP would you like to see in future episodes. I would like to thank our Twitter user Anas for sharing feedback on EIP-1822 that we did recently. As he writes, thanks for making this happen at Cat Herders and all the presenters. EIP-1822 and proxy architecture was giving me a hard time. We are glad that it helped you. Stay tuned for upcoming episodes. Your feedback is important to us to be able to bring more informative episodes for you. You can share your feedback and tag at Cat Herders. You're also invited to join the ECH Discord. The invite link will be provided in the description box. Do hit like and share button. If you are a first-time viewer, don't forget to subscribe. Keep sharing your love with Ethereum Cat Herders. This is all of us signing out. Thank you, everyone.